Hello, game theorists. Today we are in Chapter 4. This chapter is titled Simultaneous Move Games, Discrete Strategies. Earlier we learned the distinction between simultaneous and sequential move games. In sequential move games, the players take turns. We just had a chapter on that. In simultaneous move games, the players move without knowing the other player's action. Often that means moving simultaneously. Now, we'll break up simultaneous move games into a couple of different chapters. This chapter is about discrete strategies. That means that each player has a finite number of options available to them. So games like rock, paper, scissors, you only have 3 options, so that counts as discrete strategies. The other possibility we'll look at is continuous strategies. We'll talk about that, and I believe it's chapter 5. Not entirely confident about that, but we will talk about continuous strategies at some point. You have, however, already seen a continuous strategy game. That was our first in-class game, the beauty contest. So you can put any number from 0 to 100, so there's a continuous range in that game. We also have the further distinction between what we call pure strategies and mixed strategies. So pure strategist means there's no randomization. We'll study that case first because it's just easier to grasp. Once we have that mastered, we move on to mixed strategy. That means you play a strategy at random. So when you're kids, you learn very early on that when you're playing rock, paper, scissors, you don't want to be predictable. You want to randomize in order to not lose every time. If you're predictable in rock, paper, scissors, you can always lose the game. So the first thing I'll do is look at how do we depict these games. So we had a game tree for sequential move games. Simultaneous move games are a bit different, so we'll use a different tool to study that. So what we'll do is we'll draw a table. We'll start as a 2-player game to keep things very simple. However, the same principles apply to 3 or more player games, and we'll see how that's done later. We'll start a 2-player game. We'll draw a table that shows the payoffs and how they depend upon the 2 players' strategies. So here's an example so you can see how that works. So usually I use one of my students' names, but I don't know you guys, and I don't know if you're comfortable volunteering with the game. So I'll just pick a student from last semester who volunteered. Let's say Jeffrey has 2 moves. Jeffrey can play A or B. The other player, let's see, who's the other player? Let's say the other player is Ethan. Ethan can play X or Y. The players move at the same time, so while Jeffrey is picking A or B, Ethan's picking X or Y. It's just like rock, paper, scissors, where you pick one of 3 options while your opponent also picks one of 3 options at the same time. So let's say that if Jeffrey picks A, then he gets 4 if Ethan picks X, and 8 if Ethan plays Y. Now Jeffrey's other option is to play B. So if Jeffrey plays B, he gets 2 if X is played by Ethan, and 7 if Ethan picks Y. So now I gotta write down what are Ethan's payoffs in each scenario. So let's say Ethan goes for X. Then he'll get 0 against A and 1 against B. Ethan's other option is to play Y. Let me make sure I don't run out of space, so I'll put that over here. He'll get, oh, that should be if A. So Ethan's picked Y, and Jeffrey can pick either A or B, not X. So if Jeffrey picks A, Ethan gets 3. If Jeffrey picks B, Ethan gets -1. So you can see the game written out in this form could be kind of hard to analyze. That's why we use a table. So in a table, we have to say which player is using the rows or which player is using the columns. It doesn't really matter how you write it as long as you are consistent. I'll show you how to write it in both the different ways. So first I'll make Jeffrey the row player. So that means that Jeffrey's strategies are shown in the rows of the table. So those are A or B. So Ethan here is the column player because his strategies X or Y are shown in the columns of the table. And we said that if Jeffrey plays A and Ethan plays X, then Jeffrey gets 4. And we also said that if Jeffrey plays A and Ethan plays Y, then Jeffrey gets 8. So, one very, very important convention to know, because we'll use this for the rest of the semester. In these tables, the row players' payoffs always come first. So it's always row players' payoff, then column players' payoff. So I'll fill in the rest of Jeffrey's payoffs here. So if Jeffrey plays B, he gets 2 if Ethan plays X, and he gets 7 if Ethan plays Y. So we've written out all the row players, all of Jeffrey's payoffs. Now let's fill in Ethan's payoffs. So if Ethan plays X, he gets 1 if Jeffrey plays A. If Ethan plays X and Jeffrey plays B, then Ethan gets 0. If Ethan plays Y, then he gets 3 if Jeffrey picks A. He gets -1 if Jeffrey plays B. So that's one way you can write down the game. Now I said earlier, it doesn't actually matter which player you make the row player and which one's the column player as long as you are consistent. So just to illustrate that more clearly, I'll rewrite the game in an equivalent manner. So now I'll make Ethan the row player, and I'll make Jeffrey the column player. So all I gotta do is flip those payoffs. So here's Ethan on the rows, playing X or Y. And Jeffrey has the columns A and B. All right, so we said that if AX happens, then Ethan is going to get 1. And Jeffrey gets 4. Remember, it always comes with the row player's payoffs first, because Ethan is the row player now. I've flipped it. I got to flip those payoffs as well. So now it's 1-4 instead of 4-1. This says Ethan gets the 1 because Ethan's the row player. Back here, Jeffrey was the row player, so he was getting the 4. So if BX happens, we got to flip those payoffs. Again, that's because now we've flipped who's the row player and column player. So now it's 0-2 instead of 2-0. And then for if AY happens, then Ethan gets 3 and Jeffrey gets 8. Again, just gotta flip it. And we also have -1, 7 over here. So that's how I can rewrite the game. So you write the game in this table form like that. We don't actually call it table form. The name is normal form, also known as strategic form. So now you know how to write down simultaneous move games. Now we'll go look at some examples in the next episode and do some analysis.